Thank you for joining us today for the Meritorious series, Bitcoin, Crypto, and Blockchain. I am your host, Catherine Kostreva, co-founder of Meritorious, and I'm going to introduce our panel for this session, the future of blockchain and how companies should use it. Our moderator today is Jennifer Kamrowski. She's a West Point grad who served as a quartermaster officer in the U.S. Army. During her tenure, she was awarded the Bronze Star and various Army Commendation Medals. Jennifer is Air Assault certified and a member of the All-Army Women's Soccer team. She currently works as a principal and partner at PricewaterhouseCoopers Cybersecurity, Privacy, and Forensics Practice, and is part of PricewaterhouseCoopers Digital Asset Working Group, which includes crypto. Jennifer previously served as the national leader of Ernst & Young's Veterans Affinity Group and has been a board member for the West Point Society of New York for over 8 years. She has received the Veteran Vanguard Award, recognizing women veterans in the workplace from Veterans on Wall Street and the United War Veterans Council. Thank you so much for joining us today, Jennifer.
Thank you.
Our first panelist is Dr. Rebecca Gott, an IBM Distinguished Engineer in the Z Hybrid Cloud Organization, responsible for blockchain and digital assets, offerings on the IBM Z and IBM LinuxONE platforms. Rebecca holds a PhD in electrical engineering from Tulane University, where she developed signal processing techniques to process multi-beam sonar data while working for the Naval Research Laboratory, followed by serving in the United States Air Force, where she worked in GPS development and test while stationed at Holloman Air Force Base in New Mexico. She joined IBM in 1999 in the area of high-performance computing and has held various technical leadership positions across the IBM Power and Z teams before taking on her current role. Rebecca also serves as an adjunct faculty member at SUNY New Paltz, where she teaches an introductory course on blockchain technologies and digital assets. Thank you for joining us today, Rebecca. Our second panelist is Colonel James Allen Regenor, who enlisted in the Air Force in 1982 and served as a Titan II missile facilities technician. James commanded at the squadron and group levels, as well as staff positions on the Joint Chiefs of Staff, Joint Operations Directorate, J3, and STRATCOM. He served in the White House, Executive Office of the President, as the Deputy Executive Secretary of the National Security Council for both the Bush and Obama administrations. James is founder and CEO of VeriTX, a trusted, fast, flexible marketplace for digital assets, utilizing a platform-based business model to enable aerospace and medical digital supply chains. He is also founder and CEO of Rapid Medical Parts, a digital supply chain for medical sustainment challenges. James advises on logistics, defense, and aerospace for the Blockchain Research Institute. Thank you for joining us, James. Our final panelist is Matthew Zarracina, co-founder and CEO of True Tickets, which is reinventing secure contactless mobile ticketing through blockchain. Previously, Matthew served as a director of innovation in Thales Group's innovation and ventures practice, and before that, he was a senior manager at Deloitte. In the U.S. Navy, Matthew was a helicopter pilot with 3 deployments, 2 as a pilot in the Western Pacific, and 1 as an advisor to the Ministry of Oil in Iraq. His work with the Ministry of Oil's Beji refinery is published in the Journal of Operational Research Society. Please join me in welcoming Jennifer, Rebecca, James, and Matthew. The floor is yours, Jennifer.
Great, thank you so much, Catherine. So looking forward to talking through this with our distinguished panelists. To get started, I'm gonna have a question for Rebecca, if that's okay. Rebecca, you currently lead the development of technology in support of blockchain and digital assets offerings at IBM Z and LinuxONE. Can you start us off with some industry use cases for blockchain, such as supply chain issues and how blockchain can be used to address them?
Sure, yeah, absolutely, Jennifer. And so if we take a look at supply chains, leading with that, if you look at something like global trade, which is often burdened with manual and very paper-based processes, and so you find that our data is trapped in organizational silos. There's a heavy reliance on point-to-point communications with little to no visibility. It's time-consuming and paper-based documentation. And this leads to high levels of fraud and inconsistencies across that supply chain, in addition to costly dispute resolution processes. And so what we've found working with a number of clients is that the blockchain can manage essentially that digital documentation trail, where the blockchain becomes the store of proof, that ledger containing the counterparty signatures of agreement, the audit logs of agreement, and giving regulators essentially the transparency and visibility of what's going on within that global supply chain. So an example of this is the trade lens use case that the IBM built with Maersk, where they realized benefits of increased speed and transparency for their cross-border transactions, and reduce costs through again the paperless trade. You hear what makes the popular press sometimes is just blockchains around food safety. And so if you look at challenges in food supply chains, it's a complex distribution of distributors, of the processing ecosystem involving farms, the various distributors, the retailers, all of which kind of make it difficult to ensure the food provenance. And so here we have cases of essentially blockchains being used to track the provenance of goods across the supply chain, again, increasing the visibility. You can work to have more selective recall of products if there's a contaminated product that's discovered, and ultimately increase consumer confidence. And so to bridge to other types of use cases, and actually piggybacking on the prior talk that Dan Donnie gave, we're seeing a lot of increased interest around digital assets, and particularly as regulatory frameworks are being clarified. Large financial institutions are really investing in what their strategy will be for essentially keeping custody of digital assets on behalf of their clients. And so this is a very active area that I'm expecting to see increased momentum in, and it's a really exciting space to be working in. So I'll turn it back to you, Jennifer.
Sure, thank you. James, following Rebecca's point on the supply chain considerations, we know that you co-founded Moog, which is a blockchain-powered platform for buying and selling traceable 3D printed parts and printing instructions for them, as well as traditionally manufactured parts that are scanned and assigned unique tracking identifiers. Can you tell us a little bit more about the role of blockchain in manufacturing and what other challenges it's potentially addressing outside of track and trace?
Sure. Just for clarification, I invented the technology at Moog, but founded the company VeriTX, which leverages that technology for Moog. So looking at blockchain and really tech, we started looking at tech convergence zones and started to look at supply chain and some of the problems we had. In my prior life, I ran a large maintenance logistics organization that did about 65,000 maintenance touches a year, and it was spread from the Azores to Manaus up in Kyrgyzstan. So we're always starving for spare parts. We had acquired a 3D print business at Moog, and out of that, I said, let me start looking at really what this digital supply chain could possibly look like. We put together some use cases, and one of them was you're on an aircraft carrier, you have an F-15, has supply critical mission, lives are at stake, you have a 3D printer. How can you send a part directly from an OEM out to that printer so that it be printed and put on the airplane? Really what it distilled down to was trust. So how could you put trust in the system? We then stumbled upon literally blockchain as a source of trust, and using blockchain to create a manufacturing execution system with smart contracts, using it for part authentication, using it for data rights management of the part, and so on. We created a schema that allowed somebody, an OEM, an original equipment manufacturer, to send a part directly out that aircraft carrier, print the part, put it on the airplane, and then go fly it. So using blockchain for data integrity, process integrity via smart contract manufacturing executions, and then finally for the performance integrity within the build chamber, being able to record the data layer by layer as it was built, and then point to that with a blockchain pointer to show that we had a good product. So that's kind of what we developed. Out of that morphed a whole bunch of other things around a platform-based business and so on. But what we learned was blockchain has applicability across many market verticals. What we were able to do is reduce lead times for the Air Force from 265 days on one part down to 6 hours using our solution, and 133 days down to 1 hour. And we also did some real-time blockchain and 3D print use cases. We had a flight, Air New Zealand from Auckland to Los Angeles that had a part fail. We seeded a digital part in Singapore, which they purchased, pushed it to me on premises in Los Angeles, and I made the part and was waiting for the airplane when it landed. So now all of a sudden you can change that dynamic, and we're really focused on how do you increase uptime. You increase uptime by increasing optionality. So out of the pandemic, what we're learning around chips and other parts of the supply chain is companies spent the last 10 to 15 years leaning their supply chains, and that lean took optionality out. Creating digital supply chains will put optionality back into that company's supply chain. Much like if you were making products in China and you're unable to import because of a pandemic, go figure that would ever happen. Now you can pivot quickly to Mexico or somewhere else with a digital supply chain. We're also using NFTs, non-fungible tokens, for a lot of applications, down from tokenizing whole airplanes to systems, subsystems, and parts. Also using tokens across. We've got about 14 patents pending in the non-fungible token space for industrial applications. So there is many, many uses, but for us, we look for those convergence zones around blockchain, 3D printing, IoT, and AI, and that's kind of the space we're playing in. I'll pause there.
Awesome. Matthew, can you talk to us about the entertainment industry, just kind of showing the versatility of this technology? We know that you co-founded True Tickets, which is basically reinvesting secure contactless mobile ticketing as built on a Hyperledger fabric and run on IBM blockchain. Can you tell us how this works and why venues, performers, ticket holders, et cetera, should consider adopting the solution?
Yeah, sure, Jennifer. There's an interesting common theme here, right? So when we hear Rebecca talk about TradeLens and James talk about VeriTX, and oddly enough, I'm going to talk about ticketing, which sounds kind of benign, but all these are mission critical solutions for the customers, right? So when you think about TradeLens and shipping, you think about VeriTX and 3D printing of critical parts for aircraft, and you think about ticketing, these are mission critical solutions. I think this is one of the areas that we've all found an area where blockchain can add significant value, but it also highlights one of the challenges, right? You're building solutions with emerging technology that are mission critical systems. So it's really, you really got to get it right. And one of the reasons this technology fits well in ticketing is, look, we all kind of have stories and know about problems in event ticketing, right? And when you think about ticketing, it's a distributed problem. You have multiple organizations managing aspects of essentially the same inventory, right? Whether you bought that ticket from the actual venue, you bought it on a secondary site, you bought it from a friend, right? And so when you think of a distributed problem, a distributed solution can fit very well for that. And the broad value the industry sees in what we're doing in ticketing is essentially creating a single system of record, right? So when you think of all the problems in ticketing, they essentially can be solved by answering two problems that a single system of record can do. One is this ticket legitimate? And then two, who has the ticket, or who is attributed to the ticket? So when you think of a lot of the cost and the friction in the industry today, it really just has to do with answering those two questions. And it sounds simple, but it's actually very hard to do. But now that you have distributed ledger tech, you have a way to solve it, essentially a distributed problem in a distributed way. What makes us a little bit unique relative to everyone else is there's kind of three ways to solve this problem, right? There's how Ticketmaster and some others have gone about it, which is centralize everything. The problem is most of the rights issuers, right? The content creators, the people who are issuing the tickets, they don't want to, you're ceding way too much power to a centralized authority. The second is blow it all up. And I would say that's really not an option either, right? So everyone's kind of saying, oh, we need to have peer-to-peer marketplaces. Well, you already have marketplaces that work pretty well, right? Like you've got SeatGeek, you've got TM Plus, you've got all sorts of things. And so when you look at it, what we've built actually is an underlying infrastructure layer that just makes ticketing more effective, more transparent, more efficient. And when you can do that, you can remove significant costs from the system and really change it and make it work a lot better while leveraging a lot of how the industry works today.
Awesome. Rebecca, we're seeing breaches around the cloud and IT architecture. Unfortunately, on like a weekly basis, it's really kind of a space that's on fire in a bad way. While blockchain creates all these additional layers of control and security, there's still some hesitancy to adopt perhaps what folks don't understand. Can you explain to us a little bit about your perception of the security risks and what's inhibiting this mass adoption?
Sure. Yeah, absolutely. So blockchain networks, just like any other mission critical data, sensitive data, are always subject to breaches. Attackers looking to basically breach the system And in the case of particularly cryptocurrencies, digital assets, is if you manage to breach the system, you potentially are walking away with essentially the private keys, which essentially is the asset. And so you may hear about breaches of crypto exchanges where essentially private keys are compromised and the attackers essentially transfer that money, that cryptocurrency, out of that exchange into wallets that they hold. And so blockchain, particularly those holding the end asset that's natively transacted on the blockchain network, the tokenized assets or the digital assets, are definitely ripe area for breaches. And so within the public blockchain space, protection of the private key is paramount. So the paradigm is if you own the private key, you own the asset. And so you want to make sure that you never have those private keys in clear text anywhere within the system. And you want to make sure that you're protecting those private keys from the threat of insiders that could be compromised, and certainly from external hackers. And so part of the principles that we advocate is essentially principles around zero trust, where you don't trust anyone, even those within your network perimeter. And so you want to restrict the privileges essentially to just what is necessary. And so your system administrators should have really no access to the encryption keys. They should have no access to the data, the encrypted data at rest or in flight. And so building up the technologies that provide these features through privacy ensuring capabilities, through hardware security modules that can wrap the private keys with root wrapping keys that are always held within that HSM domain. So you're never holding those private keys in clear text is one way to go. You'll want to invest in, I'll say, confidential computing capabilities, where you're protecting the workload while that workload is being run in memory. So if we switch from the idea of protecting the private keys, which tends to be, at least in my mind, one of the biggest, I'll say, security threats, is basically how you go about doing that. If you look at other areas, such as protecting smart contracts. So smart contracts essentially are those business logic which governs the transaction. So you want to ideally run those smart contracts in protected memory enclaves where the system administrators don't have access to that memory enclave. And further, you will want to look at methods to protect your CI/CD pipelines. You want to work on essentially protecting to ensure that no malware is injected into your CI/CD pipeline that's building your smart contracts. And so you really want to have this holistic look and mindset of protecting that blockchain workload essentially from end to end. And so it's definitely an area that I work very closely with a number of clients on, and particularly as a lot of the protections have been and breaches have been high profile. What's been really fun about working with those in the digital assets industry is that they tend to be some of the most security savvy and security conscious clients that I work with because of the importance of security in this domain.
Thank you. James, a little bit more about VeriTX, if you don't mind. It being a marketplace for digital assets using the platform-based business model. I know you alluded to the example you had with the Air Force, but can you tell us a little bit more about the digital supply chains in the aerospace industry? Maybe a couple more examples?
Yeah, sure. We see quite a few examples right around being able to do just-in-time inventories or parts printed at the point of need. We're also seeing examples in aerospace on GE having a GE True Engine that they invented with Microsoft to track engine hot section parts and so on. So really it's around uptime, most of these examples, all the way down to, they're looking at blockchain use in the airline industry for loyalty and rewards type of schemas. So there's quite a big play. But for us, I think all of us on the panel, if we have to mention the word blockchain when we're trying to describe what the use case is, then I think we failed. What's going to happen is blockchain will become a general purpose technology, much like the 12 protocols or so that make up the internet. I think we know a handful of TCP, HTTPS, and TCMP, but nobody mentions any of that. They just say email or they say World Wide Web. So in the industries, I think you'll see that transition and you'll realize that it has really been adapted when you have to stop saying, we're using blockchain for this. It's really going to be scaffolding with so many different use cases, whether it's going to be ticketing, as Matt mentioned, or some of the other applications that we've mentioned before. Blockchain provides that transparency, that immutability, that trust rail that's lacking. And it allows us in the aerospace and defense industry to really move beyond. One other example I would mention is really for us, it's any type of digital asset. So anything that can be digitized, whether it's intelligence information, which could be comment or SIGINT or some sort of video intelligence. Again, that stuff is put into a digital media, and then the source material and the provenance of it matters as it tracks. We've also looked at NFTs, non-fungible tokenization, for things like air tasking orders, for bomb target selection through that whole process. It's called the JFIDL, the Joint Forces Air Component Commander or the Joint Forces Commander could use blockchain for the TIP-FID, which is time phase deployment process. We could use a lot of these technologies either on the commercial side or the military side directly now to make for ease of planning and ease of execution. I'll pause there.
Awesome. Matthew, within M&E and the contracts in that industry and the kind of focus on intellectual property as well as the opportunity to kind of increase profits through consumption-based pricing, what are some of the challenges with that, and how is the industry sort of collaborating to come together to develop some standards to address those concerns?
Yeah, standards and usage are kind of a chicken and egg problem, right? So, what comes first, standards or usage? And you have organizations like the Open Music Initiative that are working on developing universal standards with people in the industry. And to some degree, they're struggling a little bit because they honestly don't know how this technology is going to be used, right? So sometimes usage has to drive standardization. I would say that some of the challenges, it depends on the medium and what you're doing, right? So in ticketing, one of the greatest misconceptions is a ticket is an asset. A ticket's not an asset. A ticket is a license. And so one of the things that we do, we really are essentially an access management platform, right? So when you digitize a ticket the way we do, we make it a license, and that you can put rules around that license. You can enforce those rules in an automated way in a digital environment. And when you do that, you can do that fairly well. When you look at other types of mediums or media like music or movies or digital content, you can really control the access to it, but you really can't actually control the rights around it, right? I can attach a song to a non-fungible token, but there's nothing stopping anybody from recording that song at high fidelity and just putting it out, for public consumption, right? And so it's one of those, you really need to understand the medium, the model, how it's going to work, and what your kind of litmus tests are, right? I think Apple proved what the price of honesty is for music. You pay 99 cents or $1.29 to listen to a song 24/7, 365, right? You could still go get that song for free on the internet somewhere, but they figured out what the cost of honesty is. So I'd say some of the challenges are just understanding what are the things that you're trying to monetize and how are you trying to monetize them, and what's a requisite or kind of a baseline understanding of like what you can enforce, right? So like I said, music and movies and digital content, there's a huge opportunity there, but you really actually can't manage the rights because somebody's going to be able to copy that material and take it, quote unquote, off chain, right? So how do you then build systems that kind of account for those edge cases, but still drive efficiencies in the broader industry? And those are some of the challenges that they have to face in those industries.
I've spent a lot of time helping clients with digital royalties, so I have a good appreciation.
Oh, it's painful, isn't it? Oh my God.
Yeah, good times. Lightning round, 1 minute left. If you could each provide us with what you think is next, what trends you're seeing in your respective industry, you're kind of looking forward and around the corner, what would you kind of offer to this group as your final visionary statement? Rebecca, we'll start with you and just kind of go to James and then to Matt.
Sure. Yeah. So I think we're going to see mainstream financial institutions offering digital asset custody services to their end clients moving forward.
All right. I think we're starting to see an inflection point. We saw kind of the first couple of waves come in with the ICO craze. Now we're going through the DeFi craze. Now the next craze is going to be decentralized manufacturing or decentralized X, whatever the X may be. And what we're learning is there's quite a bit of value once you unmoor cryptocurrency from blockchain and use blockchain in these other applications. Matt?
Yeah, one of my mantras with this technology is blockchain doesn't suffer from an adoption problem. It suffers from a user experience problem. And when you look at the technology today, a great analogy is programmable thermostats. Remember, I don't know, we're probably all old enough to remember the one that you had all the buttons and you had to press it for a second to do this and nobody ever used it, right? But now we all have Nests or smart thermostats that essentially watch us and allow us to program our house from our computer, right? The technology really isn't that much different, but they've made the user experience so much better, right? And that's what's likely going to it's continuing to progress in our space. I think one of the things that we figured out at TrueTickets that's smart is how to really abstract the complexity of the technology away from the user. Now that we've done that, I think you're starting to see broadly in ticketing, your organizations that can actually move the needle on this, right? Leagues, teams, associations that have significant power over how tickets are distributed and what technologies are leveraged are now starting to see, hey, I can potentially take advantage of this and do it in a way that either doesn't really disrupt the patron journey or actually improves the user experience. And so I think as we start to figure those things out, the improvement in the user experience is really actually what's going to drive adoption.
Awesome. Catherine, I think we're back on time here. Thank you guys for the wonderful commentary. It was extremely insightful.
Jennifer, thank you for moderating. Applause, applause. Thank you for putting the emojis on the screen. Rebecca, James, and Matthew, it's incredible the work you've done, the platforms and companies that you have built. I know our audience today has learned a great deal about the various applications of blockchain, as well as what the future may hold in store for this extraordinary technology. So thank you again.